another example of the same table, but in this time we are, let's leave this one down here for a minute. We have two different data types. So this would be if you were using a parameterized query coming from your application, or maybe you're using a stored procedure, or you're just using variables inside of your script to hold parameters. And in one case, we have an email parameter that's defined as an varchar 2000, and another one that's defined as a varchar 250. What's going to happen with this when we run these?
Well, it's probably going to be quite similar to what happened in the last one, because you're still comparing a varchar to an nvarchar, or what I think it's the other way around. You're comparing a varchar to an nvarchar.
Yep. So let's take a look and find out. Because I don't know the answer until I look at the plan or the messages window. So the first one is going to take all the time, 23,741. You may remember that number from the previous example, and 4 reads here for the right data type. So by simply using the right data type, we're able to get the result set thousands of times faster. Now, if we go back to the plan, we can see, oh, look at that, yellow triangle with the exclamation point, and convert implicit. It's having to go convert that entire column over to that data type. And it's doing a whole lot more work now because it can't use the index for an index seek like it was doing originally. So while we're training, practicing for this, George said, well, what if we just, I think you said this, George, what if we just converted that parameter going in? So what we're taking is an example of varchar 2000, and we're saying, let's just cast that varchar 2000 to a varchar 250. So what do we think is going to happen when we do this one? Is that going to make any difference?
Well, I don't know. Let's run it.
Good answer. I like that. So let's take a look. Oh, look at that. 4 logical reads. That's a whole lot less work than we were seeing before. And the execution plan, yes, it's able to do the index seek.
Is that because it's converting the nvarchar before it's looked up in the query or in the table?
Yeah, exactly. So what's happening without the cast is the email variable is coming through as an varchar, and then SQL Server says, oh, I can't compare that, so let's convert all of these user email fields to be varchar or to be varchar to match it. Instead, it's doing this cast, or it's doing a conversion that's being specified by the person writing the query once on this variable rather than once for every row in the result set.
So to go back to your chart from earlier, that was the hidden chart everyone should know about. So if you were comparing, if you were doing it the other way, if you were comparing a varchar to an nvarchar, wait, is that the way? If you were doing it the other way, so it's a varchar in the table. If it was an nvarchar in the table and you were comparing it to a varchar, would it convert the other way and be just nice and fast?
Yes, if the user email column that we had here was an varchar instead of a varchar, and it was trying to go the other way without this cast here, just an example like this one, for instance. No, if it was this one, it would take the user email, because if it was an actual varchar, and because of the order of precedence, it would say convert this email parameter over to an varchar, and it would run faster that way. Yes, good question. All right, so you can fix it up this way by doing a cast sometimes on your parameter to get it to go against the order of precedence to convert it to the type that you want to use on the query. But where you can't do that easily, or as easily, is when you start looking at joins. So let's take a look at this table, a couple tables here. So first we have user logins, Alt F1 to bring up the parameter, and user email is of type varchar 250. Okay, then we'll look at login history, and user email is of type nvarchar 500. So how does this happen? Well, One reason that this kind of thing happens is that uh, the login history table was maybe added 2 or 3 years later and by a different developer, and the original developer added it as type varchar, and then the second developer, or varchar 250, then the second developer came along and said, well, I'm going to be smarter about Unicode and be able to work in other environments with different languages and all that. So I'm going to make it an N varchar just to be safe, and I'm going to go with size 500 because, I mean, although email addresses could be longer than 500, there are probably better chance of them being less than 500 than there are of being less than 250. So, I mean, it was a logical decision-making process that could do that. But let's look at what happens when we do the join between these. So all we're trying to do is to look up the last login date for me using user logins and login history tables. And when we run that, we can see it created a work table as part of this, which is something in TempDB that's being used. It did on user logins, 9 scans and 23,738 page reads. So a whole lot of work being done there. And when we look at the execution plan, well, the first thing that hopefully catches our eye is the yellow triangle with the exclamation point in it that says convert implicit on user email. And when we look at the plan, we get an index scan on user logins and an index seek on login history. The index scan is why things are so slow. The index scan is returning almost 1.3 million rows that then need to be joined up against what we're getting out of the login history table. So how do we fix this one?
Well, can we just do the convert before it executes again? That seemed pretty simple.
Like the cast, like this example right here.
Yeah, the cast.
So really what we're doing is we're saying, let's take the one that is an N varchar and let's convert it to a varchar, in this case, 250, so the types match. Now, technically, if that h.user email coming from login history could have something longer than 250 characters, in which case it would be truncated or lost there. But let's see what happens when we try and run this, doing the cast. Now, keeping in mind, I'm hitting Control-R to go back to the previous results before I run the new one. Previously, it took 23,738 plus 7 logical reads overall. When we run this one, okay, 41 scans and 164 reads. That's a whole lot better, plus the 7 on login history. So, yeah, that's definitely better. Could we do even better? Okay, so let's say you're working in an environment where you control the schema on everything. It's not a vendor product where they've set it up where you can't change it. One of the things we could do is we could change the user type on one of the columns so that they match. So what I'm going to do is I'm going to drop the index that's there on user email. I'm going to change the data type, and then I'm going to add the index back in. And that also has a user email and the login date. So if we do that, yeah,
I
go
would
ahead,
say
George.
that seems a little risky because isn't the other one nvarchar 500? So wouldn't you want to convert the varchar to an nvarchar?
Yeah, good point.
You usually want to go to the most accepting data type if you're going to do that permanently on a database.
Yeah, really good point. However, that is not the demo I planned. But looking at it, that would be a much better option than what I'm doing here. So, yes, that is correct. That would be better than doing it this way. But let's just see what this does to fix it if we do this change. So we drop the index, we change the table. Oh, we need to drop. There's a view I was using down here that we're going to drop that's keeping it from being able to change that column. Okay, we drop that view. Yeah, I don't have time to rewrite this to the way you said to go, George, but you're right. That would be a much better way to do it than to be converting it this way.
Well, I guess it really depends on the size constraints of your database. If you're trying to shrink the data, then yeah, this would be the better way to go, I think.
Or if you know for sure there's never going to be Unicode characters, which that's kind of a tough thing to say. Yes, I absolutely know for sure that that's never going to be the case.
Well, you could write a quick check query.
How do we run a check query of all possible emails that might be put into the system in the future?
That's true.
Yeah, that's the trick. Okay, so this is running. It's taking a minute to run. And keep in mind that by changing this and then adding the index back in, yes, it's taking a minute or two to run here, but that's a minute or two you have to do once, maybe during after hours or a downtime. So now to see if we can get this to be less than 23,000 logical reads here by changing the data type on that column. So we're going to change it to varchar 250 instead of nvarchar. Let that run. That'll take just a minute to run. And to do that, we have to drop the index that's on it in order to be able to change the data type and then put the index back on when it's done. So that'll take just a moment to run. Okay, that finished. So let's see how this compares. Was what, 23,000, something like that, reads before. Now we're down to 4 logical reads and 4 logical reads, and actually 4 physical reads. Let's run that again and see if the physical reads changes. Yeah, more stuff was cached in memory that time. So yeah, basically 4 logical reads on each of those tables instead of the 23,000. That's quite a bit faster. Okay, so let's put that data type back to nvarchar. And what we're going to do is we're going to pretend for a minute that we can't change the table. Let's say this is a vendor supplied product or something like that. And if we break that, well, if we change that, it could cause problems for future support from that vendor. So one of the things we could do is we could create a view. Now, assuming it's okay to create views. And what we do is create the view and then create a clustered index on it. And the view is going to contain the converted, oops, I had a typo in my demo here, not varchar 25, but varchar 250. And in order for the view to be indexed, we have to use the with schema binding parameter, which makes it so that you can't, the view keeps the table from being changed. So you have to drop and recreate the view if the table changes. But once that gets back to the nvarchar data type here in just a moment, we'll be able to do this option of creating a view and then creating the, there we go, it finished. So first we'll create a view, then we'll create a clustered index on that view. And of course, this has got a lot of rows in this table, so this may take a minute. And then we're going to take that original query, and instead of querying the login history table, we're going to query the view of login history, which has a clustered index, which means the view has been materialized by creating a copy of that converted data into the clustered index, the indexed view. And let's see how that changes things compared to the 23,000 logical reads we were getting originally. Now, when we run this, quick results, and we're back to 4 logical reads on either of them. So by creating the view and changing the query to use the view instead of the table directly, that's another way to get around some of those implicit conversions. If we run that again and we look at the plan, we can see that although there's a convert going on, it's not nearly as bad as the implicit convert that is happening when we do it the other way. So that's an option. I'm going to drop that view. It's just an example for now. Let's look at a couple other things. So what I'm going to do is throw some values into this transaction history table that have today in them and just see how that goes. And then we're going to do some similar things that we did before, looking at dates. Or instead of looking at varchar, we're looking at dates. So we have here transaction history. What data type is transaction date? Well, if we look at that, transaction date is of type varchar 10. So one of them we're passing through a date, and then we're passing through a date converted to a varchar 10. Let's just take a look at those two as an example first. So the only real difference is the cast to varchar 10. And when we run those, we can see that one of them has 6,600 reads and the other one has 4. And the execution plan is 100% with a clustered index scan versus 0% with a clustered index seek. That makes all the difference in the world in how fast your query is going to run and how much CPU is taken up as well. But if I was going to do the cast of a date, instead of just saying cast it to varchar 10 using the default structure, I know that it was formatted in that column with the year dash month dash date format. What I would do is actually use the cast to convert it to the exact same format. So if somebody changed the settings on the server, that the date format would still work if it was in a different format. And that still comes through at 4 logical reads there. Okay, so then what we're going to do, I'm just going to update the user logins column, or sorry, the column C in the user logins table to be the same thing as the user ID. User ID is an int, but the column C is a varchar. So I've seen this with a lot of vendor supplied products we've worked with over the years where they store like some kind of an ID inside of a varchar. And I've seen a query like this where somebody says select from a table where instead of column C, it would be an ID equals a fixed number like this with no quotes around it. So that is an int data type and it's comparing it to a varchar. And when we run that, we end up with 42,000 logical reads on it. And when we look at the plan, we end up with the yellow exclamation and a convert implicit. Okay, so how do we fix that? Well, it's simple. You just have to do it as a string. And the question here is, do we need it as a n varchar or is a varchar string being passed in? So in one example, I'm going to quote it, and the other I'm going to quote it with the n in front of it for n varchar. And let's see how those compare. In this example, 4,300, which is better than what we were getting before on the number of reads. But if we do it with the right data type of a varchar, we get 7 logical reads to scan that entire thing rather than, let's go back and look at the very beginning. If we compare all 3 of these, converting an integer and having to go through all those others took 90% of the time versus 10% versus 0% with the right data type. 42,000 reads versus 4,300 reads versus 7. And the difference here is those numbers get bigger and bigger the bigger the table is. So that's one of those, you just shows the importance of having the right data type. And that wraps up this demo now. Thanks for watching. I'm Steve, and I hope you've enjoyed this video. If you like it, please click the thumbs up icon. And if you want to subscribe, click subscribe to our channel and click the bell icon to get notified when we have new videos. All right, have a great day.